Over the past 2 decades, the topic of climate change has continually made headlines around the world. Initially, much of the discussion revolved around the evidence supporting the claim that climate change was occurring or not. As evidence has continued to mount in favor of climate change, the discussion has begun to turn to its causes. Today, we only have begun to address on a public level how we will begin to adapt to the environmental concerns associated with those changes. This presentation aims to examine some of the human health concerns of climate change, mostly those from natural disasters, and ways in which public health officials can begin to mitigate and prepare for those inevitable changes. I'm Philip Gilbertson. This is
Alex Ramsey.
And this is Zach Koch.
To establish the context, we'll first take a look at what climate change is and then briefly characterize some of the environmental changes that have implications for human health. After that, Zach will examine characteristics of some of the major natural disasters which have profound impact on population health. Finally, Alex will address recommendations for how public health and emergency management officials can begin to prepare for changes in the natural environment. As mentioned in the introduction, there's been much debate on whether climate change was occurring. Today, there is consensus among nearly all leading world scientists that climate change is in fact a reality. This includes the Intergovernmental Panel on Climate Change, sanctioned by the World Meteorological Organization, the U.S. Global Change Research Program, and countless other world-recognized bodies. So what is climate change? According to the International Energy Agency, climate change refers to the change in regional temperatures, precipitation, and extreme weather events associated with an increase in the greenhouse effect. We'll discuss the greenhouse effect in a minute, but it's important to understand that temperature differences across the Earth drive all weather phenomena. Therefore, changes to that temperature balance have profound impacts on the associated weather patterns, to include everything from precipitation to droughts to wildfires, snowfall, and extreme weather events. The greenhouse effect refers to Earth's natural absorption and release of energy from the sun. This process is controlled by the composition of the Earth's atmosphere. Put simply, the greenhouse effect allows sunlight to reach the Earth's surface, warm the Earth, and then either radiate the heat back into space, or like a greenhouse, trap the heat in the atmosphere. How much energy the atmosphere traps is dependent on the specific wavelengths of energy passing through the various greenhouse gases. Amongst those gases, water vapor is by far the most prevalent. With that said, water vapor concentrations are largely fixed. We cannot add more water vapor nor remove enough to significantly change the greenhouse process. The concentration of other greenhouse gases, primarily carbon dioxide, has fluctuated and does contribute to the change present today. The diagram at the bottom of this slide shows the natural absorption pattern of water vapor in blue. You'll note between 7 and 20 microns that there is little absorption of energy. This is the window that allows heat to naturally escape to the atmosphere. In contrast to the natural absorption pattern of CO2 or carbon dioxide, which is depicted in red, this shows a significant portion of wavelengths that are absorbed by CO2, which normally pass through the water vapor window. Therefore, significant increases in CO2 indicate that the atmosphere will retain more heat or energy. This next slide shows the best estimates of greenhouse gas concentration over the last 2,000 years. It should be noted that although these gases occur naturally in small amounts, they are more significantly produced by man-made sources. Although most scientists agree that man-made factors are largely responsible for climate change, there does persist debate among a few. However, based on observations and computer modeling, scientists have been able to argue that human effects outweigh those from natural forces alone. The important takeaway is that either way, man-made or natural, climate change is happening and officials must begin to prepare. The catchphrase associated with climate change used to be global warming. However, that term is somewhat misleading. Although the overall temperature of the Earth is expected to rise, the specific effects will vary based on region. With that said, increased temperatures are expected to increase glacier and ice melt, thus increasing sea levels, increase precipitation and patterns, which are also expected to alter, and along with temperature changes, will greatly affect agricultural production, water supplies, air pollution, and vector-borne diseases. Lastly, temperature changes will drastically affect the frequency and intensity of extreme weather events. This graphic depicts the Earth's temperature in 1880s on the left and the temperature in 1980s on the right. These two time periods were then compared with the average temperature from 1951 to 1980. This comparison shows a clear warming trend in the latter part of the century. This graphic also shows the temperature variations mentioned before across the Earth's surface. To further illustrate some of the changes expected in the United States, the following two slides display some of the forecasted weather effects based on computer models. The graphics were all taken from the U.S. Global Change Research Program. The upper left depicts the projected temperature changes based on a low and a high emission scenario, with much of the U.S. experiencing a significant increase in the average temperature. The right-hand side shows the projected change in precipitation by season. The precipitation change is depicted as percent change from the normal baseline, with areas in the southwest and south anticipated to receive much less rainfall. Lastly, the bottom left shows the projected change in water supply for counties in the U.S. Coupled with increased temperatures and less rainfall, significant portions of the U.S. will begin to face severe or extreme water shortages. On this next slide, we see in the upper left the observed trends in hurricane power dissipation. If we associate the observations of other measures of climate change, we can surmise that we have seen a general increase in the intensity of hurricanes in the North Atlantic, North Atlantic region, and a decrease in intensity in the Eastern Pacific. The large graphic on the right depicts the number of 100-degree Fahrenheit days observed in the past and projected through 2099. The increase may be most apparent in the central and southern U.S. However, it should be noted that the projection also calls for 100-degree days in areas historically not accustomed to such extreme heat. Finally, the graphic in the bottom left shows the forecasted change in heavy precipitation events based on either a reduction in emissions or a continued increase. Should emissions rates continue, we can expect to see an increase in major flooding events in the Pacific Northwest and the American Northeast. What's important to remember is that changes in our environment are intrinsically tied to the effects on our own human health. The chart on this slide from the Centers for Disease Control and Prevention highlights some of the impacts of climate change on human health. In order to assure the safety of the public's health, officials must begin to take measures in anticipation of climate change. In some areas, this may mean preparing for more intense disasters normally experienced in that region. In others, it may mean preparing for disasters unfamiliar to the public. In any case, climate change presents a significant challenge to the safety of public health. To further discuss the public health challenges presented by natural disasters, I'll turn the presentation over to Zach.
Climate change will play a role in several different types of natural disasters. Specifically, change will occur in disasters that develop based on high and low precipitation scenarios. Natural disasters, as we know, can be very dangerous and destructive events, and as climate change may cause these events to shift in one direction or another, it is important to know what to expect from each type of disaster. If we understand where we are at now with these disasters, we may have a better idea of what changes to anticipate with the climate differences. So we are going to go through several different natural disasters to discuss some of the characteristics and facts for each one. Starting with severe thunderstorms, we have seen throughout the world 16 million thunderstorms will occur each year, while at any moment at least 2,000 storms could be happening. Storms occurring in the United States contribute about 100,000 of those 16 million each year. Of the total number of storms, about 10% may be included within the severe category. However, climate change may increase all of these numbers. A thunderstorm is classified as severe when it has one of at least three of the following: hail, high winds, or tornadoes. Two of the main components have specific characteristics, which include the hail being 1 inch or greater and the winds reaching at least 50 knots or 57.5 miles per hour. Thunderstorms may occur on a seasonal basis. In the United States, thunderstorms are most often during the spring and summer months, while most often happening in the afternoon or evening of those seasons. However, to say that these are the only times this occurs is unwise. Severe storms are possible all year and at any time. It is also possible to narrow down when the storms are often based on the location within the country. With the varying elements that come along with thunderstorms, the lightning, hail, winds, and tornadoes all have potential to cause severe damage. In many cases, thunderstorms result or end in other types of natural disasters, one being the tornadoes that we have mentioned already, and the other being flooding, which we will discuss in further detail later, as well as fires. The lightning from the storms may cause those fires, while also the potential for rare strikes. The hail can increase from the minimal 1 inch. The strong winds, which can gust over 100 miles per hour, can blow down trees, power lines, and cause damage to mobile homes. The damage to power lines may create their own problem with the loss of power to a large area, which can hinder the infrastructure. A thunderstorm requires several different pieces to form. Those are moisture, rising unstable air, and a lifting element. The thunderstorm will move through 3 different stages, including the developing, mature, and dissipating stage. The developing stage has a cumulus cloud that move up with air and includes very little rain, if any. The mature stage is still in an upward motion, but precipitation begins to develop. During the mature stage, hail, heavy rain, lightning, winds, and tornadoes are most likely to occur. The downward draft from the precipitation occurs, which is the dissipating stage. Thunderstorms come in many different types and ways, including single cell, multi-cell, squall line, supercell, bow echo, mesoscale convective system, mesoscale convective complex, mesoscale convective vortex, and derechoes. These types vary in intensity, duration, as well as the size. We move on to flooding, which is the most common worldwide natural disaster. As discussed during thunderstorms, flooding usually follows heavy rainfall. However, that is not the only way. Damaged dams or levees and ice melting are all potential reasons for flooding. One of the main components of a flood is the timing. They may develop in minutes, or it may take days for a flood to become dangerous. When it comes to flooding, many factors contribute to the flood risk. Three categories cover the factors, including meteorological, human, and topographical. Examples of meteorological factors include precipitation, as we have talked about, temperature, season, and several others. Human factors look at the floodplain habitation, efficiency of drainage, upstream and general land use. Topographical factors include the soil type and moisture, vegetation, and runoff patterns. The severity and risk of flooding all depends on these and many varying factors that all play a role in the development and intensity. Riverine is based off of the terrain and weather. Flash floods are actually included in this category, where narrow valleys collect water very quickly and water moves faster and in shorter duration. Flash floods are usually characterized by quick rise as well as intense destructive flow. Lake level fluctuation flooding is ultimately lake area flooding. This type of flooding can occur with erosion along the lakes, and the best way to combat this is to build at higher elevations. Ground failure occurs when the land is compromised, resulting in landslides, mud flows, and alluvial fans. Finally, coastal flooding occurs when ocean water moves inland and exceeds the regular tidal surge. Landslides are the next natural disaster that can be associated with high precipitation. They include a wide range of ground movement, including rockfalls, failure of slopes, as well as debris flows. Usually gravity is the main factor in a landslide. Other may contribute, though. They occur with heavy rainfall, which may lead to more erosion along waterways, while the rain may also cause weakened earth due to saturation. Earthquakes can cause landslides due to unstable land, with a magnitude of a 4.0 and higher causing them. Volcanic eruptions will produce ash, rain, and debris, which are all potential elements for loose flows. The speed of each landslide can vary, resulting in different levels of destruction or threat. Some may move only at a millimeter per year, or they may move more quickly, resulting in more damage. Debris flows can move at a speed of 200 miles per hour, depending on the slope. In the United States, 25 to 50 deaths may occur each year because of landslides, while worldwide they cause hundreds of thousands of deaths and injuries. Damages can also be costly. In the United States, they cost about $1 billion in damage each year, while worldwide it costs hundreds of billions of dollars to pay for the damage costs by these disasters. However, the monetary amount is increasing over time as landslides occur with changes in weather. Moving on to disasters associated with a lack of precipitation, we start with heat waves. A heat wave is an extended period of high heat and humidity. When looking at a heat wave, the temperature is usually 10 degrees or more above average. In 2010, 37 states in the United States had recorded highs during the summer months. Heat waves result in more deaths than hurricanes, tornadoes, and earthquakes combined. The problem is with the subtlety of heat waves. Most do not consider heat waves as dangerous as many other natural disasters, and that may be because of the destruction factor that most others have. Heat waves come and go with little physical damage from an environmental or surrounding perspective, other than it may take a toll on the human body as well as wildlife. The urban heat island effect is the risk of heat emergencies going up in urban and suburban areas due to the larger human population in close proximity, such as large cities throughout the nation. The environment has a difficult time dealing with external heat as well as the heat generated by the large populations. It is noted that temperatures within urban settings do not drop as quickly as those in rural areas. Next, we look at droughts, which are an extended dry period in a natural cycle. They are a slow onset disaster because they are influenced by the lack of rainfall. Droughts may last anywhere from months to years. Droughts are seen as relatively predictable compared to other natural disasters, since they follow the lack of rainfall and adjustments can be made. However, one cannot account for the duration of the drought and the impact it may have. The characteristics of a drought are expressed with the use of two things: drought index and intensity, duration, frequency. The drought index looks at all the data from rainfall, snowpack, stream flow, as well as other sources of potential water. It supplies a number that helps explain the precipitation for a certain area. The indices can help predict droughts ahead of time. The second component, the intensity, duration, frequency, are considered in models that work with meteorological droughts. Several different types of droughts exist. Meteorological droughts look at the amount of dryness compared to the average as well as the duration. This type of drought is region-specific based on the area's conditions and precipitation. Agricultural droughts look at the meteorological components along with the impact it has on the agriculture of a region. The amount of precipitation as well as the groundwater levels are considered here, as well as the soil water deficit. Hydrological droughts look at the water in streams and reservoirs. They are related to meteorological droughts but also look at how land is used to check for damage. Lastly, socioeconomic drought is a term used to account for the economic deficit caused by the three previous types of drought. It considers the lack of goods due to the damage caused by the decreased rainfall. Finally, we look at wildfires, which can be started in several ways, ranging from other natural events to intentional causes. Lightning, as we have talked about already with thunderstorms, is a somewhat regular occurrence. Every day, the earth is struck by lightning over 100,000 times, with at least 10% of those strikes causing a fire. In the United States, man-made fires are the most common start for wildfires, and at least 4 out of every 5 wildfires are caused by people. These fires may be caused by accident or on purpose. The intentional setting of a fire can be looked at in 2 ways. The first is arson, while the second one is used to develop farmland. Droughts or dry conditions increase risk of devastating fires, as we have seen in California. These dry conditions may be dependent on the seasonal weather conditions each year throughout the world and country. Ultimately, the United States sees 1.2 million acres burned each year because of these fires. If the fire is large enough, it may create its own weather too. Ultimately, it alters the current weather in the area, causing a change in the atmospheric conditions. This alteration in weather can potentially result in other natural disasters, as we have discussed already, including landslides or flash floods. As already noted, a global cycle of fires is due to the rainfall, dryness, and lightning by season. In Canada, fires occur naturally during the summer. In South America, between August and October, fires are usually started by humans for different reasons. When we look at Africa, where burning occurs because of the dry seasons. The public has to constantly be aware of all the disasters we just discussed. However, it is more than just being ready for them. The health impacts and concerns that come with each disaster need to be understood as well, because disaster mitigation can only get you so far. That is why it is important to look at the essential public health services and the phases of emergency response from an emergency management perspective as well as a public perspective. It is important to know that human health impact and concerns that can impact a community. And as we have discussed already, climate change may increase the potential for health risks as well as create new risk of its own. Climate change is not only changing public health issues for those of us here in the United States, but everywhere around the world. However, we may all be impacted differently depending on our location and surrounding threats. This slide has very generic types of concerns and problems for each type of disaster. I will briefly go into more detail as we go down the list. Thunderstorms cause a variety of health concerns throughout the population. The major concerns are the injuries caused by the events that follow a severe thunderstorm in many cases. Flooding is usually the main culprit for death associated with thunderstorms. However, tornadoes that accompany these storms can injure over 1,000 people each year and kill 50. Lightning strikes may not be the most common, but they do happen. The United States between 1959 and 1990 had 250 injuries because of lightning and 90 deaths each year. Storms have also shown to play a role in asthma attacks. Due to the strong winds and rain, pollen is released into the air, creating a problem for those with respiratory health concerns. The change in temperature, moisture, and air conditions also provides conditions for sickness throughout the entire population. Rain also provides a vehicle for pollutants such as car oil, fertilizers, and antifreeze to contaminate freshwater sources. Finally, strong winds and hail are all events that can cause damage to vehicles, homes, and utilities within a community. In the last century, 8 million fatalities have been caused by flooding. In many cases, drowning is not the lead cause of death. Deaths are most often attributed to physical trauma, fire, electrocution, carbon monoxide poisoning, and heart attacks. Later on during floods, infectious disease and illness may become a concern. The reason for disease is due to contaminated water, food, as well as mold growth within homes after a flood. Common illnesses include malaria, respiratory infections, and diarrhea. However, the risk of infection all depends on the living conditions and development of that specific community. Flooding will also damage personal property from basements to vehicles being destroyed by water damage as well. As stated already, landslides can cause about 50 deaths each year. Overall, the frequency of this type of event may increase or decrease the occurrence of injury and death. The movement of a landslide will cause direct trauma to an individual causing injury, while suffocation is a potential threat for those who get caught within the slide. If a landslide occurs on a major roadway, it may create other potential threats not originally considered. Obstruction may separate parts of the population from vital resources such as water, hospitals, or healthcare, as well as sources of communication. Also, depending on the size of the slide, property damage will occur, which may result in gas leaks, damage to water or sewage lines, as well as the loss of livelihood through the damage of livestock and crops. Heat waves can take a toll on the human body, especially if it is already in a susceptible condition. In many cases, heat waves will increase in damage done as the duration and temperature increases. Individuals who are out in the weather for any extended period of time will potentially go through dehydration, which causes further results of shock. Trauma, burns, GI tract diseases, hyperglycemia, and even diabetes are all other potential health risks. It is important that as climate change continues by the end of the century, the United States is on pace to have more than 150,000 deaths in the largest cities throughout the nation. The threat of heat waves may also increase the potential for droughts, which then result in their own sets of concerns. Droughts occur and begin on a chain reaction. An extended drought will decrease the amount of water supply in general. The use of water will move from a focus on crops to consumption just to survive. The lack of water for crops will limit the season as well as supply for self-use as well as export for economic stability. If food is not easily available, many will suffer from malnutrition as well as dehydration throughout the population. Natural resources of water may also become contaminated due to stagnation. Disease will increase due to the stagnation, which will result in decreased health for humans as well as livestock. A drought will also decrease the air quality. The lack of moisture will cause dust and other particulates to circulate in the air, while wildfires will be more common because of dryness causing smoke. The obvious threat of wildfires is the possibility of severe burns and suffocation due to fire. The most wide-ranging concern is the smoke produced by such a fire. The smoke from a wildfire contains carbon dioxide, carbon monoxide, nitrogen oxides, water vapor, particulates, and many other compounds. The composition of the smoke all depends on what is burning, so there is potential for far worse chemicals to be present. The smoke is not only a direct respiratory problem, but it may be more easily absorbed by the skin, causing health concerns as well. Wildfires can be very difficult to control, resulting in property damage throughout a region. Again, California is a clear example of the devastation that wildfires can produce. Again, climate change is a wide range of influence on the various natural disasters and the how, when, and what damage they can do, but it also has its own concerns. Air quality will decrease if looking at pollution, ozone, and fine particulate matter in the air. Allergens will increase, causing those with respiratory problems to have more regular issues or attacks, as well as causing new cases in those previously unaffected. Temperature extremes will be changing growing seasons, as well as causing an increase in natural disasters. Disease prevalence will increase in a variety of ways, especially vector-borne disease. Pest or insect control may become more difficult with changing seasonal trends. As discussed with droughts, food security will become an increasing problem with the lack of appropriate food production. Mental health and stress disorders may increase due to the stress placed on the human body through natural disasters and lingering climate changes. Finally, the emergency response system will be overtaxed due to the increase in emergencies. Demands will be high on first responders as well as resources to combat each type of event. In many cases, vulnerable populations will require the most attention as climate change continues. Children, elderly, sick, and the poor will all be high-risk groups. In many cases, they may already be at a disadvantage in terms of health status or ability to withstand change, which makes them susceptible to overall risk. Ultimately, every region throughout the United States may experience climate change in a different way, and we will look at that next with Alex.
Not all regions will have the same disasters to be prepared for. In this section, I will summarize the disasters affecting specific regions of the U.S. and any preparedness and mitigation measures that should be taken to protect against any potential health and environmental threats. Starting with Alaska. Over the past 60 years, Alaska has experienced a drastic difference in warming speed from the continental United States. The Arctic summer ice is melting at a much quicker pace with climate change. By mid-century, it could be gone. Ultimately, this has an impact on aquatic ecosystems as well as coastal erosion that other coasts have been experiencing already. The glaciers melting in Alaska and British Columbia are playing a role in ocean circulation patterns as well as in overall sea level rise. The permafrost temperatures, while increasing, may affect several different components of Alaska, including dry landscape, as well as a larger risk for wildfires. The increasing ocean temperatures are leading to changes in marine fishing, which is a large portion of the United States commercial backing. One of the most important effects to note is the impact that climate change is having on the natives of Alaska. However, their culture continuously adapts. Alaska has taken several different steps on various levels to prepare for or mitigate the changes in climate. Homer, Alaska had its own global warming task force that developed its own climate action plan. The plan looks at different concerns for the city that may affect its economy, as well as a potential change in weather. A few specific strategies they looked at were working to develop an economy that can handle the change, as well as changing building and maintenance plans. The United States Army Corps of Engineers picked those 204 communities that need relocation due to erosion of land. The natives are working closely with the Army Corps of Engineers to find appropriate areas to relocate to. The state government in 2007 made the Alaska Climate Change Subcabinet. This group worked to provide information to combat climate change. Since the ice is melting quickly, the ocean is becoming more available for trade and travel. The Navy has had to develop new maps and disaster response plans, as well as making new connections and partnerships with stakeholders. Next, we will discuss Hawaii. Hawaii and the Pacific Islands are concerned with many different changes based on the ocean. As the ocean continues to warm up, the coral reef continues to weaken. The reef is bleaching, as well as having to combat disease outbreaks. The acidification of the ocean will hinder the growth of the reef as well. Not only will the reef be affected, but the marine life who live within it will be as well. As the sea level rises, the salt water will contaminate the freshwater area throughout the islands. Increasing temperatures will also threaten the local wildlife and plants, which may end in extinction. Ultimately, the rising sea levels of the sea will lead to coastal flooding and erosion. The varying threats to the islands will force a migration of local inhabitants, which may result in the loss of customs, beliefs, and language. A couple different ways that Hawaii is fighting the effects of climate change are through policy and developing frameworks. Maui and Kauai are two counties that have policies in place. Have policies in place that restrict building within certain distances from the shoreline. The state of Hawaii uses a 20 to 40 foot separation, while the two counties have more strict regulations. The Climate Change Adaptation Framework is used to look at climate change impacts and what steps to take to fight it. The team coordinating the framework would develop different sectors that climate change would impact. They would use vulnerability and risk assessments and plans to develop better infrastructure. Now we'll talk about the Great Plains. The increase in temperature creates a demand for water and energy. Development throughout the region will be hindered while communities compete for resources. The change in temperature throughout every season is causing a change in the crop cycle. Measures will need to be taken to manage the new growing seasons as well as managing livestock. The landscape fragmentation is causing problems with species adaptation while the climate changes the habitat. The Great Plains already have some communities that have been affected by the change in climate with an increase in natural disasters. However, this is not the end point by all means, as disasters will continue to increase in frequency. Various departments within Austin have worked to develop plans to reduce greenhouse gas emissions. The Austin Water Utility Department prepares for water shortages during droughts, as well as preparing for pollution during rainfall. Private organizations work to protect wetland resources throughout the plains. The motivation to protect wetlands is not because of climate change, but it helps prepare the ecosystem for the change when necessary. Wyoming also works to protect wildlife from climate change. The United States Department of the Interior and the U.S. Fish and Wildlife Service give funding so states can develop state wildlife action plans. They encourage projects that minimize climate change. The northeastern region faces significant challenges due to climate change. Much of the population in the region is centered along the coast in some of the largest U.S. cities. With such a large population in general, there are particular concerns for vulnerable populations living in those cities. Projections for climate change emphasize an increase in the number and intensity of heat waves, a significant threat of coastal flooding due to sea level rise, intense extratropical storms, and an increase in precipitation-driven flooding events. Many of the key infrastructure facilities are co-located in major coastal cities, presenting a concern during major weather events for grid-type failures. When compared to other areas, the Northeast has taken a more proactive approach to adaptation measures. In Massachusetts, the state has incorporated climate change into its planning measures to include public health activities. Still, most local municipalities have done little to address health concerns that may arise from climate change. Given that local responses are often the most important during an emergency event, this is an area that needs to be focused upon. Finally, at-risk populations need to be identified. Heat waves and flooding disproportionately affect people in large cities, as evidenced by the heat wave in Paris, France in 2003 or Hurricane Katrina. Public health preparedness should focus on those most at risk. The Midwest is the region that is most adaptable for climate change and the disasters associated with it. In this region, we can expect to see an increase in the number of heat waves as well as humidity. These risks pose the most dangerous threat to the public health sector. There will also be an increased amount of precipitation that could lead to a higher frequency of flooding events. Flooding events can be known to lower the water quality of the areas that they affect, and this would have a profound effect upon the Great Lakes. The lakes are vital to the region's health as they provide commerce and balance to the ecosystems. Pollution and increased temperatures could lead to an increase in the toxic algae and invasive species populations in the summer, and more erosion from less ice cover and more intense winds in the winter. This region needs to be prepared for heat waves during the summer months. They can have the greatest effect upon vulnerable populations, so arrangements should be made for these populations during these times. These can range from home visits to ensure the elderly and disabled populations are taken care of, to opening cooling centers for those that are homeless. Land use policies will need to be reevaluated as well in order to improve upon agricultural practices, energy use, and floodplains. The Southeast region has a variety of concerns that it will have to take into account. First, it has a high risk of flooding as well as rising sea levels. It also is the highest energy user of all the United States regions, which can create a very large problem within infrastructure. While the sea level rises, the warmer temperatures also increase the temperature of the sea, which creates a potential for more common and stronger tropical storms. The Gulf has a large population of vulnerable communities that live in areas most likely to flood. As the change in temperature and increasing flooding occur, vector-borne diseases have a higher chance of occurring, and that creates a health risk throughout the population. Preparedness and mitigation measures must be taken to help the Southeast plan for climate change. Coastal planning is critical to preparing this region from the rising water levels. Public health officials will have to watch for trends of new cases of vector-related diseases. The region will also have to focus a lot of attention on vulnerable populations throughout the Gulf and the rest of the region, while also working to build up their infrastructure to make the entire area more prepared. Moving on to the northwest, there is an expected average annual increase in temperature of 3.3 degrees Fahrenheit to 9.7 degrees Fahrenheit in this region from 2070 to 2099. This increase in temperature will affect the region in many ways. There is an expected decrease in summer precipitation, an increase in the amount of snowmelt, an earlier snowmelt season, and drier conditions. An increase in river-related flood risks is expected to be seen due to the large accumulation of snowmelt in the region's rivers. Basins that are mid-elevation, temperature-sensitive, and have mixed rain-snow watersheds are those that are most vulnerable to the changing snowmelt. Drought is expected to occur as well due to the 30% decrease in summer precipitation by 2099. These dry summers will cause water levels to drop across the region and could destroy the habitats of many aquatic species. Because of this, reductions in hydropower production up to 20% could be required to preserve in-stream flow targets. What's more is that the lack of precipitation will lead to an increase in the number of wildfires seen in the region. By 2080, the median annual area burned in the northwest could quadruple to 2 million acres. The map displayed indicates the increases in area burned if regional temperature and precipitation changes associated with a 2.2 degrees Fahrenheit change in global warming occur. What then can we do to mitigate these climate changes? The city of Portland, Oregon performed a study in which climate models were used to project future water supply and demand. They determined that with the increased winter precipitation, earlier snowmelt, and drier summers, there would be a 2.8 to 5.4 billion gallon decrease in reservoirs. Their proposed solution to this problem is to expand groundwater supply and/or surface water storage. This could be a potential solution to the water shortage and drought problems, however, it might not be enough. Over-allocation of existing water supply has been a problem in this region as well, so restructuring how and where the water gets allocated using flexible management could provide progress in adapting to the expected water shortage. Another potential solution is to find an alternative energy source other than hydroelectric power during the summer months. Currently, hydroelectric power makes up about 70% of the electricity in the northwest region. If a cheap alternative energy source could be used in the summer months, the region's dependency upon the snowmelt could be diminished and less drought, wildfire, and aquatic habitat destruction would be seen. Adaptation actions to decrease forest vulnerability to wildfire exist, but none are appropriate across all of the Northwest's diverse land. Strategies that can be used to include removing excessive vegetation and dead fuels through thinning, prescribed fire or other methods, and promotion of biodiversity of species to decrease stress from overcrowding and reduce sensitivity to disturbances. The Southwest region, the decade of 2001 to 2010 was the warmest in the 110-year instrumental record, with temperatures almost 2 degrees Fahrenheit higher than historic averages. With fewer cold air outbreaks and more heat waves were seen as well. Between 1970 and 2003, warmer and drier conditions increased burned area in western U.S. mid-elevation conifer forest by 650%. Models project a doubling of burned area in the southern Rockies and up to a 74% increase in burned area in California. Droughts and summertime heat waves are projected to be substantially hotter, more intense, and longer lasting than in history. Urban public health is directly affected through increased risk of heat stress, and infrastructure is affected due to electric power generation strain. The increased temperature and drought are causing earlier spring snowmelt and shifted runoff, as well as increased fire occurrence and burn area in this region. This is part of the reason that there is an expected increase in the prevalence and severity of flooding. The risk of flooding events in low-lying delta systems is projected to more than double by 2050 and have an eightfold increase by 2099. Combine the snowmelt effects with the increases in atmospheric moisture in California's coastal ranges, and the risks get even higher. This can affect aquatic species as well as water quality in the area. Similar to the Northwest region, prescribed burning, mechanical thinning, and retention of large trees can help some southwestern forest ecosystems adapt to climate change. Denver Water and the U.S. Forest Service Rocky Mountain region are hoping to restore over 38,000 acres of forest lands through mechanical thinning, fuel reduction, creating fire breaks, erosion control, decommissioning of roads, and reforestation, all of which are viable ways to reduce the prevalence of wildfires. The City of Peoria, Arizona provides technical assistance and rebates for xeriscapes, or dry landscaping, which is a technique using plants that thrive in dry conditions. To mitigate and adapt to the increasing drought effects, renewable surface water supplies can be used while reserving groundwater sources for use during extended droughts. The development of new water supply strategies, including water reuse, aquifer storage and recovery, and desalination, could help to meet the demand for water in the summer months. Water-efficient appliances could save water as well. Rain barrels are yet another effective low-tech way to reuse water on-site and avoid waste. Their benefit is twofold: reducing localized flooding and providing water for landscaping. The City of Chicago offers rebates for people who purchase these, and this could be adopted in the Southwest as well. The best way to combat heat waves is to decrease the urban heat island effect. This can be accomplished through the use of white roofs and reflective surfaces, tree planting for shade, energy-efficient appliances, solar power generation to minimize the strain on power plants, and provision of cooling centers to the public. An example of these strategies is depicted in this chart. On a national level, there is no one-size-fits-all adaptation solution to the challenges of adapting to climate change impacts. Solutions will differ depending upon context, local circumstance, and scale, as well as on local culture and internal capacity. Most adaptation efforts occur at the local and regional levels and include land use planning, provisions for protecting infrastructures and ecosystems, regulations related to the design and construction of buildings, roads, and bridges, and emergency preparation, response, and recovery. Because most has taken place at the local and regional levels, sharing best practices, learning by doing, and iterative and collaborative processes can help support progress when dealing with new and recurring natural disasters. Federal agencies can be of great assistance in this aspect. They have clearinghouses set up for storing data, resources, any lessons learned, and best fit practices of specific regions that have already enacted climate change adaptation plans. These agencies can provide this usable information as well as any financial support needed for implementing adaptation plans. If a disaster should occur across state and geopolitical lines, federal agencies can help any recovery actions. Finally, building public awareness is something that needs to be done if we are to become fully prepared for natural disasters across the country. Federal agencies can help with this more than anyone. After all, it will take a combined effort on many fronts to combat climate change and the natural disasters associated with it.
Overall, we have looked at how climate change is currently and what climate change is currently and how it will impact our communities in the future. It is important to identify all the potential threats and understand what can be done to combat them all. We thank you for your time. Have a nice evening.